Continuing from our last video segment, we were investigating the work done by a vector field given here x y squared comma x squared y plus 1, and the work done as we traveled from the point 0, 0 to 2, 4 on two different paths. So one of the paths we chose to use was a line segment 2 and 4, and the other path we chose to follow a parabolic path, so slightly concave upward to the point 2, 4. And whereas one time we did this calculation and the work was different, and this time both sets of calculations came out with a work equal to 36. So it can be coincidental sometimes, two paths with the same amount of work. You know, it's like finding two routes to work or to school that take about the same amount of time. But in general, we don't expect those to be equal to. So here is the difference maker. The difference maker is actually in our vector field. The vector field in this case has components m and n. And if we were to look at this in a way that we looked at a couple of days ago in class, m with respect to y is equal to 2xy, and n with respect to x is also equal to 2xy. And if these are equal, then that's a conclusion that we've had before. That means the vector field f of xy is conservative. And if the vector field is conservative, again, I told you before to think of this as a conservation of energy. And so it doesn't matter which path you choose, that work would come out to be 36 no matter which path we look at. In class, we may also have looked at an example where we choose several paths between 2 points to determine if the amount of work is the same or not. So here is the term we're going to write out and define. Okay, it's called path independence. And here it is paraphrased. You can read the book for a more technical definition. Paraphrased version is, it doesn't matter what path we take, the work will be the same between the starting and ending point. So what that means is, if we have a point here, in the case we were at the origin 0, 0, and we wish to end here at the point 2, 4, if I chose to go this way and meander and go this way, that work would be equal to 36 joules if we're using joules. But if I were to take a different route and go this way to get to that point, the work would still be 36. It doesn't matter which path you choose, the amount of work is independent of the path. So that concept is called path independence. Now, how we can use it to our greater good, we will determine soon.